Good morning, dear students. This is your physics class. We were continuing to chapter 2 of physics, that is units and measurement. And the topic that we have to discuss today is errors in a measurement. Dear students, measurement is the part of physics. In every experiment, we have to measure a physical quantity, and in any measurement, every measurement, errors often occur. Every measurement is done with the help of some instrument. While making the measurement, some uncertainty gets introduced in the measurement. As a result, the measured value is always somewhat different from actual value or true value. That means the deviation of the measured value from the true value of the physical quantity is called error. That means we can say the error in a measurement is equal to the difference between the true value and the measured value of the quantity. That is, the formula for error is true value minus measured value. For example, let us take an example. Z, the value of acceleration due to gravity, is 9.8 meter per second square on the surface of the earth, and experimentally when we measure it we calculate different values which are not actually equal to 9.8. The values may be 9.79, the values may be 9.6, the values may be 9.5, the values may be 9.9, the values may be 10, and all these values are deviated from the true value, that means 9.8. That is, there are some error in our measurement. What is the reason behind it, we are uncertain about that, but there is some error, and that error can be defined as the deviation of the measured value from the true value. Now, dear students, the arithmetic mean of all measurements can be taken as the true value of the measured quantity. For example, you are taking 10 records of the from your experiments, 10 measured values. You are taking 10 values, then you have to calculate the mean of all those values. You will calculate mean x bar is equals to x1 plus x2 plus dot 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 xn whole divided by n. That means sum of data divided by number of observations. Sum of observations divided by number of observations. You will calculate the mean. Whatever value you get from here, that will be considered to be the true value of the measured quantity. Thus, if a1, a2, a3 and an be the n measured value of a physical quantity, then its true value a is given by the arithmetic mean. That is, a mean or a bar is equals to sum of all the observations measured divided by number of observations. This can be written as a bar is equals to 1 upon n summation of ai from I equals to 1 to n. This is called mean value or true value. Now, let us talk about absolute error. Absolute error, what is absolute error? If we consider the mean value, that means x bar or a bar, as the true value, then it is clear, dear students, that every measured value will be deviated from the true value. Okay, so the difference between the true value of the measurement and the individual measured values, it is known as absolute error. What? The deviation from the true value, the deviation of the measured value from its true value means mean value, is called absolute value, absolute error. So now a bar is true value, that means mean value, and a1, a2, a3 up to an are the measured value. Absolute errors are calculated as follows. So delta a1, this is denoted by delta a. So delta a1, that means first absolute error is a bar minus a1. Second absolute error is a bar minus a2, where a bar is equals to mean of all the observations. In this way, delta an equals to a bar minus an. So nth absolute error, absolute error in the final measurement, absolute error in the last observation is delta n equals to a bar, that means mean value, minus nth observation. Now mean or final absolute error, mean or final absolute error. So let us take the mean of all absolute errors. Absolute errors means delta a1 plus delta a2 plus delta a3. You have to take all these sums and number of observation divided by n. This will give you the mean of absolute errors, and thus this is known as final absolute error. So dear students, one thing you have to keep in mind, that here while calculating the mean absolute error, you have to take the modulus of all the absolute errors. That means you have to assume all positive values. No negative deviations will be considered. All deviations must be positive. So delta a bar is equals to 1 upon n and sum of all the absolute errors. That is, delta a bar is equals to mean absolute error equals to mod delta a1 under mod delta a2 plus under mod delta n whole divided by n, number of observation. In this way you are taking the mean of all the absolute error taken positive divided by taken positive. Now delta a bar is equals to 1 upon n summation of mod of delta ai, where I is equals to 1 to n. Thus the final result of measurement of a physical quantity may be expressed as a is equals to a bar plus minus delta a bar. That means you have to consider the error. It may be above the real value or below the real value, so you have to consider plus minus sign here. Clearly any measured value of a will be such that a bar minus delta a bar such that a lying between, the real value will lie between a bar minus delta a bar and a bar plus delta a bar. It will be accurate if equality holds. Now we will talk about relative error. Let's see. It is the ratio of mean absolute error to the true value of the measured quantity. So relative error delta a, it is denoted by delta a, is given by delta a bar divided by a bar. Del a equals to delta a bar divided by a bar. This is known as del a. This is rated as del a equals to delta a bar divided by a bar. It is also known as fractional error, and when it is expressed in percentage, the relative error when expressed in percent is called percentage error, and thus percentage error is given by delta a bar divided by a bar into 100%. Okay dear students, so we will understand it in the better way using an example. Let's see an example, and how can we solve the numericals concerning it. In an experiment, the refractive index of glass was observed to be 1.5, 1.56, 1.54, 1.44, 1.54 and 1.53. Calculate the mean value of refractive index, mean absolute error, fractional error, percentage error, and express the result in terms of absolute error and percentage error. So dear students, how can we calculate the mean value of refractive index? You are easily familiar with the mean or arithmetic mean, sum of observations divided by number of observations. We have been provided here first, second, third, fourth, fifth and sixth. There are 6 observations in total taken as refractive index of the glass by the experiments done. So first question is to find the mean value. Simply we have to add all these given observations and divide them by the number of observations, that means 6. So you will get 9.06 divided by 6, and this will give you 1.51. 1.51 n bar. N is for refractive index. N bar means you are getting, n bar means n bar represents the mean of refractive index. Okay dear students, let's continue. Absolute errors in measurements are, you have to just find out the deviation from true value. This may be considered as the true value. So first absolute error delta n1 can be calculated as n bar minus n1. Simply you get by subtracting the given values. 1.51 is the true value or mean value minus first observation 1.545. This will give you 0.06. In this way you can calculate the absolute errors in particular measurement. It may be negative or positive, dear student. You can find delta n1, delta n2, delta n3 by subtracting the corresponding measured value from the mean value. Dear students, you can easily calculate it. It may be positive or negative. Now mean absolute error is the third question. Mean absolute error, you have to take simply the mean of all the absolute errors which you have calculated earlier above. Now the mean absolute error can be given as mod n1 plus mod n2 plus mod delta n3 plus mod delta n4 plus mod delta n5 plus mod delta n6 divided by 6, and putting the values of all the absolute errors and dividing by 6, you will get 0.0433, which will be approximately equal to 0.04. This will be answer number 2. This is mean absolute error or final error, you can say. Now fractional error. What is the true value, dear students? The true value was 1.51. This is mean value. So what is the final absolute error? Mean absolute error. The mean absolute error was 0.04. So the fractional error or relative error delta n is given by del n is given by delta n bar divided by n bar. That means error, final error divided by original value, that means true value. So you will get 0.03 as a result. Now if you convert it into a corresponding percentage value by multiplying it the given value with 100, you will get 3% as the percentage error. Hence the refractive index in terms of absolute error can be written as n bar plus minus. Always use plus minus. After that you should write the error with the measured quantity, true value of the quantity. So the final value is 1.51 plus minus 0.04 in terms of absolute error. Now in terms of percentage error, this is 1.51 plus minus 3%. Okay dear students, I hope you all understand what I have taught to you today. So I am giving some questions for practice. Practice it regularly and do it in your copy in a very neat way, proper way, and submit it in the next class. I hope it will be easy for you. So today's class is over, and we will meet in the next class. Till then, thanks all of you. Okay, goodbye.